our unit circle lesson. So if you have not read through the vocabulary, the I can or the why, please do so now. And then pause the video to complete the warm-up. Part 1, you're going to use your calculator. Make sure you're in degree mode. And you're going to fill in the table here. And then the second part, you're going to examine the table and write down some observations looking for trig expressions with the same values and maybe trying to make some connections on why that is occurring. Okay, so if we look at our complete table, please check that you have the same values. If you don't, and they're dramatically different, I'm thinking you did not have your calculator set in degree mode. So make sure you do that. If you don't remember how to do that, please ask during class, and then we'll go over that again. All right, some things that I'm noticing is that even though it doesn't really make sense when we're making a triangle, but when we talk about the angle and standard position, we know that we can have a negative angle, and that negative indicates a clockwise rotation, and I can create a sine ratio for that negative. It looks like that value is also negative. However, it doesn't seem to be true that every time I take the sine or the cosine of a negative, then I would get a negative, because that didn't happen in this case. Here I get a positive. So there must be something more to that rule of when I would get a negative and when I would not get a negative. Because then I look here and I've got cosine of 135. And that angle's positive, but the cosine ratio ends up being negative. Likewise here, I have a cosine of 150. That's a positive angle measure, but that ends up being negative as well. Now, if we kind of highlight those that have the same value, sine of 5 and cosine of 45. And if we think about our opposite over hypotenuse and adjacent over hypotenuse in a 45, 45, 90 triangle, those legs are congruent. They have the same measure. So if we're taking 5 over 7, it's going to be the same 5 over 7 for sine and cosine. So that makes sense to me. This is a little peculiar, though. A cosine of 150 is what I meant to highlight. Cosine of, 30. And the sine of 120 have the same value. That's a little intriguing. This one here. Looks like the sine of 0 equals 0, and so does the sine of 180 degrees. That's kind of curious. And then, well, these aren't the same, but they're opposites. They're both 1. One is positive and one is negative. I'm also noticing that the sine of 90 degrees is positive 1, where the cosine of 0 is positive 1. So any of those observations that you made would be valid. And now we're going to kind of explain why that is happening. So what we're going to look at today is a special circle, and it's called the unit circle. So it's a circle whose center is at the origin. And the radius is exactly 1 unit. So we can fill in these ordered pairs pretty quickly. So this would be 1, 0. That point. The radius rotates up here. This would be 0, 1. And then the radius rotates over here, and this point would be -1, 0. And this point would be 0, -1. And we could travel around that circle again and hit all those same points. If you recall from the video lesson, angles and standard position, these were our quadrantal angles, angles that ended up on the axes. And what we want to do is use that as a jumping off point. Oh, let's maybe back up. Let's talk about it. So any angle in standard position that ends up in this quadrant, any one of these angles, right? This one or this one or this one, those angles end up in quadrant 1. And we know from a previous lesson that measure of angles in quadrant 1 are in between 0 and 90 degrees. Then we pass that quadrantal angle of 90, and we're in quadrant 2. And then we pass to quadrant 3. And we know the measure of any angle in quadrant 3 has to be in between 180 degrees and 270 degrees. And then we enter quadrant 4, where my measure is going to be in between 360 and 270. And so let's label our quadrants. And our points here, 1, 0, 0, 1, -1, 0, and 0, -1. All right, and what we're going to do is we're going to draw in our angle in standard position to get these answers. So sine of a 0-degree angle, that would mean the initial side and the terminal side are on top of each other and are on the x-axis. When I have this type of situation, I don't have a triangle, right? There's no angle there whatsoever. So there is no side opposite, or that side opposite has a value of 0. And then because we're using the unit circle, the radius is always 1, or the hypotenuse will always be 1. So that ratio would be 0/1. Let's maybe write our SOHCAHTOA on top here as well. All right, we'll do our next angle. Let's do our 30-degree angle. So now what we have is a 30, 60, 90 triangle. We drop that perpendicular down and we can see that triangle there. The hypotenuse here is equal to 1. So the sine of 30 degrees would be the side opposite over my hypotenuse. And we know how to get that shorty from the hypotenuse. We have to divide it by 2. So the sine of 30 degrees is 1/2. and the sine of negative 30 degrees, and we know that negative means to rotate clockwise. So we would go underneath the x-axis this time. And now my side opposite has to have a negative value, right? Because this y-coordinate would be negative. So again, the negative indicates the direction. And then I've got the same ratio, opposite over hypotenuse. So this would be negative 1/2. And then we look at cosine of 0 degrees. And go back up to this picture. Now the adjacent and the hypotenuse are the same exact measure. And in this unit circle, they're exactly 1. So my ratio is 1/1, which reduces to 1. Now we can get the cosine of 30 degrees. So we have this triangle in here, but this time the cosine is the side adjacent. So we know we take shorty and multiply it by the square root of 3. So this would be the square root of 3/2. All right, now we're working with a 45-degree angle. So let's draw that one in. Drop our perpendicular. So this triangle, if we move it out, this is a 45, 45, 90 triangle with the hypotenuse equal to 1. So if I need the sine ratio, and the cosine ratio will be the same, so we can get 2 for 1 here. I would have the side opposite over my hypotenuse. And we know, how do we get a leg when we know the hypotenuse of an isosceles right triangle? Again, we are going to divide this time by the square root of 2. And then we like to rationalize that. We get square root 2/2. All right, so now we're moving on to 60 degrees. So that's going to be an angle slightly larger, but still in quadrant 1. Dropping our perpendicular, this whole thing is 60. If we take that 60-degree triangle out, well, again, we have a 30, 60, 90 triangle, where we know the hypotenuse has to equal 1. Again, we have to get shorty first. So we get this side, which we already have from the previous example. And then we would multiply by the square root of 3. And now I'm noticing that the cosine of 30 is the same as the sine of 60. And that's because these two angles, acute angles in a right triangle, are complementary. And then these are co-functions of each other. So sine and cosine. So that's going to happen every time. And so I think we can use that relationship that we just discovered to get what the cosine of 60 would be without any work at all. And the cosine of 60 would be 1/2. Right, now we're going to do the sine of 90. And what happens this time is we have this situation. Okay, the first time we had the horizontal situation, now we have the vertical situation. Okay, this time there is no side adjacent. There is the opposite and the hypotenuse. So they're both equal to 1, right? The side opposite and the side and the hypotenuse. So the sine of 90 is exactly 1. And since there is nothing opposite or adjacent, then the cosine of 90 is 0. All right, now we're going to map into our second quadrant, because this angle 120 exceeds 90 degrees. Right. What I'm going to do now, though, to get my sine and my cosine for this angle measure is I'm going to drop a perpendicular like we did before to the x-axis, but I'm going to focus on what's going to be called my reference angle. And the reference angle is going to be the 180 that I would travel to get all the way to this part of the x-axis, the negative part of the x-axis, minus what I've already traveled, right, the 120. And so my reference angle here would be 60. And we already have the information for 60, but I think we have to make some adjustments. So if I take this one out, here's my hypotenuse. We need to get shorty, but if we notice, shorty's value here is going to be negative, just like we had in that negative 30 degrees. Our y-coordinate was negative, or our opposite. Well, here our adjacent is negative. But we would still get it the same way. We would divide the hypotenuse by 2. So the cosine of 120 is negative 1/2. However, the sine is going to stay positive, and the sine of 60 we know is square root 3 over 2. We move to 135. That's greater than 120. We drop our perpendicular, the x-axis. We're going to find our reference angle. And our reference angle here is 180. Subtract 135, which would give us 45. So now we have a 45, 45, 90 triangle again. I know the cosine and the sine will have the same value, and I can use what I learned in the first quadrant here. That value is square root 2 over 2. But again, the adjacent side is going to have a negative in front of it, because we know those x values on that part of the x-axis are negative. So the values are going to be the same. Square root 2 over 2, square root 2 over 2, but the cosine is going to have to be negative. One more into this second quadrant. At 150. But our reference angle for 150 would be 180 minus 150, or a 30 degrees. So now we have a 30, 60, 90 triangle. Again, we can reuse that information from the first quadrant, except we have to recognize that the adjacent side, so when we build our cosine ratio, that those will have a negative. And then I go back to cosine of 30, square root 3 over 2. Note that needs a negative, and the sine of 30 degrees would be 1/2. And then we end up back on the x-axis for our quadrantal angle of 180 degrees. This time, again, we have to remember that the cosine, we're not going to have a sine. We don't have anything opposite, so that's not anything bizarre. But the cosine here would be the opposite, the adjacent side, which is now -1. This whole distance there is -1 over the hypotenuse of +1. So the cosine of 180 is -1. The sine of 180 is 0. And then just for fun, we'll get the cosine of -30, which we already have up here. We had the sine of -30 was -1/2. The cosine again should have that same square root 3 over 2, and it will be positive because, again, our x coordinates here are positive. So now let's talk about what happens when we end up in quadrants 3 and 4. Right, in quadrant 3, let's just put in this angle, which would be 60 plus another 180. You can see that these 2 points are 180 degrees apart from each other. You see the half of the circle, but we have to account for we already rotated 60 degrees. So this one is 180 plus 60, or 240. We would drop our perpendicular again to the x-axis, and we would get that reference angle. And that reference angle is going to be this time 240 minus 180. So the whole 240 we travel, subtract off the 180 that we did not, and we are going to end up with 60 again. Now this time, both the x and the y coordinates are negative. So both the sine and the cosine of this angle would be negative. And then we'll do one more. Let's do the one that's directly opposite is here. Okay, we already have this one in quadrant 4. And we know that that would be coterminal, right? So this one would be 330 with a positive. Our reference angle would be 360 minus 330, or 30 degrees. And we have all that information. Here we notice that the y-coordinate is negative, so then the sine ratio will be negative and the cosine will be positive. So if we kind of just sum up what we figured out, quadrant 1, quadrant 2, quadrant 3, quadrant 4. We had quadrantal angles, and we're using the unit circle. In quadrant 1, we notice that our sine and cosine are positive. Then when we map into quadrant 2, what we notice is that the cosine will be negative, but the sine stays positive. And when we map into the third quadrant, both the cosine and sine ratios are negative. And then when we map into the fourth quadrant, the cosine again is positive, but the sine ratio is negative. And then if we recall our SOHCAHTOA, so the sine of any angle is the side opposite over the hypotenuse. The cosine of that same angle is adjacent over hypotenuse. And the tangent of the angle is the opposite over adjacent. We just kind of examine this. Okay, I can make a connection here. If I was to take the sine of that angle and the cosine of that angle, so I have a fraction of a fraction, we skip, we flip, and we change to multiplication, I end up with a tangent ratio. So the tangent of any angle is really the sine of that angle over the cosine of that same angle. Now, what does that mean to us? Now we can figure out what the sine of the tangent would be. And here I would notice positive and positive. Tangent is also positive. Here we'd have a negative and a positive, so tangent would have to be negative. Here, if we have both negative and a negative, the tangent would be positive. And now I have a mismatched sign again, so the tangent will be negative. And there's a really fun way to remember all of this. It is all students, write it differently. All students take calculus. So all three trig ratios are positive in the first quadrant. The sine ratio is positive in the second quadrant. The tangent ratio is positive in the third quadrant, and the cosine ratio is positive in the fourth quadrant.